So we're asked to figure out if this function is continuous at x is equal to 0. And that totally makes sense that that would be the point that we would be after, because that x is equal to 0 is our split point in the graph. So there's a big question of, is it going to be continuous at that value? All right, so the first thing to notice is that we have a piecewise function. And as discussed on our little worksheet here, when we have a piecewise function, we got to go through the checklist. And our checklist amounts to, first, do we have a function value? So does f of 0 exist? To answer that question, you're going to look at where the equal to is in the piecewise function. So the piecewise function has x equals 0. We use the second piece, x minus 1. So we will have 0 minus 1, and we get negative 1 for the function value. So that's our first condition. Now our second condition is about the limit. Now, to answer the question of the limit, I always like to draw myself a cute little picture of what's happening. What's happening here is that x is equal to 0. We, of course, have the first piece. Now, to the left, when x is less than 0, we are defined as x squared minus e to the x. To the right, we are defined as x minus 1. Now, if this two-sided limit is going to exist, we need that the limit as x goes to 0 from the left, which will be defined by this piece, we need that to be equal to the limit as x goes to 0 from the right, which will be defined by x minus 1. So if you didn't have a piecewise function at all, if you just had find this limit, what you would do is you would plug in 0, right? So what I'm going to do is I'm going to plug in the 0 here. And the question is, I want that to be equal to plug in 0 over here to evaluate this limit. And when I do that, I very nicely get negative 1. Remember, e to the 0 is 1 equals negative 1. So what that tells us is that the two one-sided limits are equal to negative 1. And so therefore, the two-sided limit, x going to 0, of this function f of x will be equal to negative 1. So we found that the function value was negative 1. We found that the limit was negative 1. And so because those two are the same, the limit is equal to the function value, we can say, yes, this is continuous at x is equal to 0, because the function value is equal to the limit.